In 2017, something extraordinary happened. For the first time in recorded history, an object from beyond our solar system zipped past the sun at incredible speeds. Astronomers named it Oumuamua, Hawaiian for scout or first distant messenger, but by the time we realized what it was already speeding away. And then, it did something impossible. It accelerated without explanation, defying the laws of physics as we know them. Was it a comet? An asteroid? Or something else? Some scientists even suggested it could be alien technology, a light sail sent from another star system. So what was Oumuamua? Where did it come from? And will we ever solve its mystery? Let's dive in. Interstellar visitors. Not as rare as you think. Before Oumuamua, astronomers had long suspected that objects from other star systems pass through our solar system all the time. Some estimates suggest thousands of these interstellar travelers could be drifting within Neptune's orbit right now. Why so many? Our solar system is surrounded by the Oort cloud, a vast shell of icy debris stretching nearly a light-year into space. Occasionally, the gravity of passing stars nudges these objects inward. Some fall toward the sun, while others are flung into deep space, becoming interstellar nomads. The reverse is also true. Our sun captures objects from other star systems. Given how many stars there are in the galaxy, it's almost certain that some of the comets and asteroids we see didn't originate here. But Oumuamua was different. It wasn't just from another star. It behaved unlike anything we'd ever seen. The discovery of Oumuamua on October 19, 2017, the Pan-STARRS 1 telescope in Hawaii spotted a faint, fast-moving dot in the sky. At first, astronomers thought it was a comet, labeling it C/2017 U1. But something was off. And like comets, Oumuamua had no visible tail or coma, the fuzzy glow of gas and dust that surrounds icy comets as they near the sun. So, it was reclassified as an asteroid, 2017 U1. Then came the real shock. Its trajectory was hyperbolic, meaning it wasn't bound to the sun's gravity. It was just passing through. This made Oumuamua the first confirmed interstellar object ever detected. The IAU even created a new classification for it. 2017 U1, the I standing for interstellar. The weirdness of Oumuamua as astronomers studied it. Oumuamua kept getting stranger. Its shape based on brightness changes as it tumbled. Scientists concluded it was either cigar-shaped, roughly 800 meters long and 80 meters wide, or pancake-shaped, flat and disc-like. Either way, it was unlike any known asteroid or comet. 2. Its composition. Spitzer Space Telescope detected no heat signature, meaning it wasn't emitting infrared radiation like a typical comet. Yet, it was 10 times more reflective than most comets, almost metallic. 3. The big mystery. It accelerated where things get really weird. As Oumuamua moved away from the sun, instead of slowing down as expected, it sped up slightly. This shouldn't happen unless something was pushing it. For comets, this push comes from outgassing ice turning to gas and jetting away, acting like a natural thruster. But Oumuamua showed no signs of outgassing. No dust, no gas, nothing. So what was pushing it? The alien hypothesis. Under Dr. Avi Loeb, a Harvard astrophysicist who made headlines by suggesting Oumuamua might be artificial, a piece of alien technology. His argument? The acceleration could be explained if Oumuamua was extremely thin, less than 1 millimeter thick, acting like a light sail, a spacecraft propelled by solar radiation. Natural objects aren't shaped like that. The scientific community pushed back hard. Most argued that invoking aliens was premature when natural explanations hadn't been rolled out. But Loeb stood firm, even writing a book, Extraterrestrial, the first sign of intelligent life beyond Earth. The dark comet theory. Other scientists proposed more conventional but still fascinating explanations. In 2023, researchers Jennifer Bergner and Daryl Seligman suggested Oumuamua might be a dark cometan object with hidden reservoirs of hydrogen gas trapped in its ice. When warmed by the sun, this hydrogen could escape invisibly, giving Oumuamua its mysterious push without producing a visible tail. This idea gained traction when they found 6 other objects in our solar system behaving similarly, small, asteroid-like bodies accelerating without explanation. One of them, 1998 Kita-6, will be visited by Japan's Hayabusa 2 spacecraft in 2031. If it turns out to be a dark comet, it could validate the theory. Where did Oumuamua come from? Tracing its path backward, astronomers found Oumuamua likely came from the direction of Vega, a star 25 light-years away. But it couldn't have originated there. Vega wasn't in that position millions of years ago. 4 other stars have been proposed as possible origins, but nothing conclusive. By now, Oumuamua is far beyond Pluto, hurtling toward the constellation Pegasus at 26 kilometers per second. It's too faint to observe anymore. So how do we solve the mystery? Chasing Oumuamua, a mission to the stars. Catching up to Oumuamua would be one of the hardest space missions ever attempted. The challenge is, 1. Speed. It's already traveling at 26 kilometers per second faster than any spacecraft we've ever launched. 2. Distance. Over 6 billion kilometers away and increasing. 3. Size. Only 800 meters long. Finding it in interstellar space would be like spotting a needle in a galaxy-sized haystack. Yet, scientists aren't giving up. Project Lyra. The plan to chase IT-18 from the Initiative for Interstellar Studies proposed to mission concepts. 1. The solar overth maneuver slingshot around Jupiter to fall toward the Sun. Use the Sun's gravity to slingshot outward at 70 kilometers per second.
Problem. Requires a heat shield and untested maneuvers. 2. Multi-planet gravity assists swing by Venus, Earth, and Jupiter to build speed. Slower but more feasible. If launched in the 2030s, a probe could reach Oumuamua by 2048. The alternative, wait for the next one. New telescopes like the Vera C. Rubin Observatory operational in 2025 could detect dozens of interstellar objects per year. ESA's Comet Interceptor mission 2029 will lurk in space, ready to chase the next Oumuamua-like visitor. The big question, is it worth it? A mission to Oumuamua would be expensive and risky. But the payoff, if it's natural, we'd learn about chemistry and physics in other star systems. If it's artificial, well, that changes everything. For now, Oumuamua remains a tantalizing mystery, one that challenges our understanding of the cosmos. As Avi Loeb puts it, the universe is under no obligation to make sense to us. But when something strange happens, we should pay attention. Will we ever know the truth? Only time and perhaps a daring space mission will tell. What do you think Oumuamua was? A comet? An alien probe? Let me know in the comments. And if you enjoyed this deep dive, don't forget to like and subscribe for more space mysteries.